Okay, we're going to get into some more advanced examples of the exponent properties on the back side. We're going to review first. You ready to copy this down? Here we go. What's the difference is that our bases aren't x's and y's. What are the bases? They're numbers. And so a big thing I want to show you is that we cannot do 5 times 5 and make that 25. No. Because this 5 has an exponent and this 5 has an exponent. So if a base has an exponent, it's kind of trapped, okay? The exponent is in control of that base. So it's not 5 to the 1. You can't, it's not 5. It's not 5 at all. It's 5 to the 2x minus 3, okay? So you got to think of that as the idea I want you to first have is that the base is trapped by the exponent. Okay, friends, ready? If you multiply the same base, so multiply same base, what do you do with the exponents? What's the rule? We're going to add them. So our base is 5, and we're going to add 2x minus 3 plus 5 minus 4x. So we're going to just combine like terms. We could have done that in our heads, but I just wrote it down just to get us warmed up. So this will be 5 to what power? Okay, ready? Combine like terms. 2x minus 4x. 2x minus 4x. What's that? Negative 2x. And then we have negative 3 plus 5. Plus 2. Okay, we're going to leave it at that. That's the product property. We're multiplying the base. What do you do with the exponents? Add. Okay, next. Here we have a fraction. So previously I said simplify the numerator and denominator separately. You ready? Here we go. In the numerator, we have another multiplication. So just like here, if we multiply the same base, what do we do with the exponents? Add them. Thank you, one person, for participating. Okay, I don't need to show the work. Let's do this one in our heads. Okay, what's x plus 3x? 4x, very good. Plus 4. Okay, we'll multiply the same base. Now let's look in the denominator. We're multiplying the 2 and the 2. The base is 2. And let's add the exponent. So combine like terms. 2x plus x, 3x. And then we have 1 and negative 5 add together to get minus 4. Okay, now we have a quotient rule, Q-U-O-T. I always like to test myself to see if I can still spell the word quotient. All right, when we divide the same base, what do we do with the exponents? What's the rule there? Subtract. So we're going to have a base of 2. Okay, ready? What is 4x minus 3x? Pay attention. Here we go. Don't zone out. It's easy, right? Okay, ready? What's this going to be? This is going to be 4 minus a negative 4. 4, I don't know what happened to my marker busted. 4 minus negative 4. It's not 0. It's 8 because the 4 and the negative 4. So we have, that's it. Okay, do you see how these look a little different, but we're using the same properties, yeah? It's almost like we switched our x's and y's, right? We made, or in the numbers, we made the numbers the bases and we put x's up here. Okay. Next rule, power property. Power property says to take, we have a power of 3 to the power of x minus 2. Okay, what do we do with the exponents when we have a power of a power? Multiply. Here we go. 2, okay, now we're going to multiply 3 times x minus what? Minus 6. Okay, what we practice in class and is one step at a time. So don't try and combine steps. That was one step. Power of a power. We got that out of the way. Now we're back to the first example. Multiply the same base. What do you do with the exponents? We're going to add them. Good. Okay. 3x minus 2x. Combine like terms. So 3x minus 2x is x. And then I see a negative 6 plus 2. Is that right? Yeah. So minus 4. Okay, not really clear on what to do here, so that's again why it's an example, and that's why I'm doing it with you. What we could do here, do you see that -2? We're going to factor out a -1 from both of those. So factor out the negative exponent. We're just trying to show you the negative power. Negative exponent rule. Okay, what do we do when we have a negative exponent? What song do you sing? From Madagascar? Yeah? I like to move it, move it. I like to move it, move it. So you move it and you make it positive. So this had a -1 here. We moved the base to the denominator and the -1 is now +1. That's it for that one. All right, 2 more. Can we do it? Yes. Oh, okay, this is exciting. Ready? This is like a preview to the next lesson after this. So it's a little, what do they call that in English? Foreshadowing? Yeah? Okay. So we don't have the same base right now, so we can't use the exponent rules. Do you see how there's a 4, a 2, and a 2? So we can't use the exponent rules with the 4 and the 2, but we can change the 4. Doesn't 4 smell like 2? Yeah, smell. Yeah. Okay. Yes, the 4 smells like a 2 because, you know what? I don't like that parenthesis. Erase the parenthesis. Okay. I'm not messing with this stuff. One step at a time. Not looking at that stuff. Okay. We're going to change the 4 to make it match the base of 2. So what is the number 4 is equal to what power? To the 2. So I'm going to change the 4. You can do that. Well, does 4 equal 2 squared? Yes. So we're going to turn 4 into 2 squared. We're just going to change its outfit. Change what it's wearing. Okay? Okay, that's literally called, ready? It's not confusing. It's called change of base. What did we do? We changed the base. Okay? So we made the 4 into a 2 squared. Why? Now we all have the same base. So we can use the exponent rules and all is good in the world. Okay. I want you guys to try this because something fun happens to this answer. So I'm going to pause the video. Are you going to pause the video at home? Probably not. Pause. All right, if we go through this quickly, there's a surprise at the end. Okay, multiply the power of power. This is the same base, so we're going to add the powers. 4 plus 1 is 5. 4 minus 1 is 3. And what do you notice? They're the same. So when you have same over same, it's equal to the number 1. Or if you want to think about it as subtraction, 5x minus 5x is 0. 3 minus 3 is 0. So you have 2 to the 0, which also means 1. Final answer is 1. Okay. Last one here. Do we have the same base with the 3 and the 9 right now, currently? No. Can we change one of them to look like the other? Yes. And what's that called? Change the base. Change of base. So we're not going to change the 3. We're going to change the 9. So the 9 will become 3 to what? 3 second power. Okay, ready? What's my mistake? Find. What's wrong with that? A lot of students would write that. The 9 is 3 squared. So what's wrong? We need parentheses. You can either put the parentheses around the 3 squared, or you could put it around the x minus 4. But the deal is we need to take that 2 and distribute it to the x minus 4. Yes? So the 9 is 3 squared. I'm so sad I have to throw this marker away. Is that sad? I like using markers or pens all the way to the end. It's very gratifying. Or chapsticks. That's like a great day when you make it to the end of a chapstick without losing it. Isn't that fun? Do you guys get excited about that? I do. But look at me. I'm a high school math teacher. Okay. Did you distribute the 2 correctly? What am I doing? What the heck? I'm doing that? Okay. Now we're going to multiply the same base. So same base is 3, which means what are we going to do with the exponents? Add 2x plus 2x is 4x. 2 minus 8 is minus 6. Okay, what are we doing now? Now we're going to look at the power in the root and change it to that fraction exponent. Okay, so the power on the top will be 4x minus 6. And the root, is there a number in here? No, so if there's no number, then it stands for 2. 2, 2, 2. You're still getting used to that, and that's okay. Ready? Here we go. Power's on the top, root's on the bottom. So the power goes on top, and the root goes on the bottom. Can that be reduced, simplified? Why? They're both divisible by 2, so we get final answer, 3 to the 2x minus 3. Yes, I have the answer key right here, just to make sure I'm not doing anything silly. Okay, after this, and if you participated in the class activity on the whiteboards where we did the really, really hard ones, the back should be so simple, okay? So this should take about 10 minutes to complete for homework. Thanks for